the chat. Thank you very much. Today, I will continue to our discussion. Yeah, we still discuss and continue discussion about the foundation of the philosophy of science first. Yeah, last week we already discussed about the landscape of the philosophy assumption, meta theory, methodology, and then become the belief and basic assumption, and then we construct the methodology, and then we, in the end, we have a specific concept, theory, and models. So today we will go to the more sophisticated landscape on the philosophy of science. Yeah, that in the philosophy of science we also have some, some major concern on the point of view to see about the science. Yeah. So you can see in the screen that in the science itself we have a two kind side, that every side is like opposite with other side. Yeah. So in the first place we have the realism's mainstream, and then the second is we have the anti-realisms. So it is the fact that the construction of the science is the merging of the these two sides, yeah, the realism and anti-realisms. In the simple word, realism means that we believe that all the science, it can be it can be explained in the logical way. Yeah. So every time, every theories, every model, every assumption, hypothesis, actually it can be proved by the science using the logical thinking, yeah, using the logical things, yeah, on the logical way, something like that. So that's why the approach on the realism is mostly like have some approach on the mathematical things, numerical things, and also modeling things and other things. Yeah. But in others say the anti-realism is belief that sometimes science is undiscoverable. So it's mean we doesn't need to to prove that science is realistic. Yeah. It should be sometimes still on the idea. It's something like it's still on the we call it the the result of the thinking. Yeah. So maybe still on the paper, it's not in the experience yet, something like that. So that would be also the science. But even it's like, the realism and anti-realism is different kind of the point of view, but let's make the science more diverse and more complete. Yeah. So we can see that the science actually need these two kind of the mainstream, which is realism and anti-realisms. So let's discuss about it. If we imagine that one, for example, that science doesn't have realism, so I think the experience scientific proof to say something, it will be missing. It will be not in here. So in that case, it will be very disaster. To it will be worse. And science is only being science. It will place in the books. It will place on the imagination and so on. Yeah? So that would be the problem. But in the anti-realisms, they believe that science is not should be not in the realistic way, but it should be in the concept, it should be in the assumption, and so on. In here, you can see that a lot of what we call it scientists that try to discover about the realism and so on. You can see from the Pythagoras, Tekmark, David, Russell, Franz, Rosenberg, Queenie, and then then the Russell and so on. Yeah, they support this mainstream. But another side that we have the concept of the pessimistic meta-induction and then under determination, Graham and also Loudon, Dewey, Van Freysen is also on this side. Yeah. So you can see that one is in the level of the scientist itself, they also have some different perspective, yeah, to see about the science on the of this philosophy. So what the important for us, yeah, as computer science student or computer scientist to see this one, that yeah, we actually, when we see, for example, we talk about the artificial intelligence, we open the opportunity that artificial intelligence is in the place to be realistic, yeah, to be realism. It should be proved by the evidence of the scientific matters, but it's also in the anti-realism is the concept, the approach that we try to develop this on the concept. It should be also accepted, yeah. So that would be the nice one. Sometimes if you are a student, and maybe you can learn from your friend that, for example, they are in the assessment of the final project, and then you will try to be, you know, to be pushed here, to inform why, the reason why you do that research, yeah. Sometimes you have two ways to explain why you do your research. The first is your assumption. It means you observe from the phenom the realistic phenomenon of the science itself. Yeah, maybe you can find based on the problem that you discover in the community, or maybe you discover on the previous research, and then you capture as your reason. So that would be the realisms. But the anti-realism may be like you do your research that the orientation is beyond. So you discuss more futuristic, yeah, something that maybe not discoverable, yeah. So that will be the nice the point, yeah. So I think in the science you can use that kind of approach, yeah, to introduce your thinking, yeah. So I encourage you. I also push you as a student, especially. You should be have a very deep critical thinking when you have some issue. For example, the issue about the artificial intelligence. Is artificial intelligence good enough or not? Yeah, maybe on the computer side, you say that, oh, that's cool. But maybe another side, you also need to open your mind that maybe the artificial intelligence is also have some issue, especially in the issue of privacy, the issue of humanity, and other issues. So that will be two kind of mainstream. Yeah. So let's back to the theory first. In the realism itself, we have several, several sub mainstream or sub of the discussion. It's the first. It's called naive realism. Yeah. In this case, is the world I see is real. So everything will be naive realism. It means everything is proven, everything is real, everything that exists in the world is real, because we can see, we can touch, and then we have a proof that the things is present in front of us. Yeah. So that's naive realism. So I think this is the realism that mostly absolute. Absolute. Yeah. There is no debate on it. Yeah. Everything is on the place. So based on that fact, it's mean like we see the pattern, we see the the condition. Yeah, it's also happen in the data. Yeah, so when we display the data, the data analytics approach, for example, and then we see the pattern of the data. So naive realism will be there because it's proven. So in the naive realism, mostly will be we also have the structural realism. Yeah, so this is like science has identified real patterns, relationship, and structure. Yeah, so this is like what we see in the world is mostly like in the form of patterns, relationship, and structure. Yeah, so it is like more natural because it will be we see that any there is any connection between the object in the world. Yeah, so that would be the nice one. I think you also can found in the like data analytics processes that if we have some the collection of data, and then we will have the pattern, and then we also have the relationship, and then also we have the structure. Yeah, and based on this one, so this is like when we have the naive realism and structural realism, so we will have the scientific realism too. Science makes real progress in describing real feature of the world. Yeah. So if we think about it, we will realize that the science actually try to explain everything that happened in the world. Yeah. So every single features, real feature in the world, try to describe by the science. Uh, from from the behavior science, we have the faculty of psychology. I think we have a lot of major that discover about the psychological things, yeah, about people. If we go to humaniora faculty, for example, we will find that the style of the language, the style of the word that will be represent the ethnic of the world, yeah, so something like that one. So I think that will be the fact of the scientific realisms. Is it's also actually like in the computer science. Yeah, computer science. Most of the algorithm that we use in the science in the computer science mostly is try to use the real feature in the world. Yeah. For example, in the computer network, we have the N colony network, and then in the machine learning or deep learning, we also have the neural network algorithms and so on. So that also one of the proof that science makes real progress in describing real feature of the world. So not only just describing, yeah, sometimes it will be inspired and then we use for developing new approach on the computer science. So that's the proof that the realism is very important on the philosophy of science. In other side, the anti-realism is also have the same condition. Yeah. Actually, the first assumption is or a feature is instrumentalism. Yeah. This is the using the theoretical concept. Yeah. So may have use in the predicting observation, but we have no ontological commitments to them. Yeah. So it's mean we can use the instrumentalization or theoretical concept. Yeah. Maybe in the research we came with the approach of simulation. Yeah, we try to simulate in the real environment, and then we have assumption based on that environment. We can see what happened in the experience. Yeah, so that will be in the instrumentalisms. Yeah, and then we also the constructive empirisms. Yeah, science aims to give us theories which are empirically adequate, but must not does not justify metaphysical claim about reality. Yeah, this is like constructing the empirism of theory. Yeah, so empirism is like we conclude or summarize something that we think is empirically adequate. Yeah. Is enough to accept as theory, as hypothesis, and so on. Yeah. So we have assumption. We have like hypothesis. It's like scientific assumption about it. Yeah. So if the Viter become A, for example, yeah, so it will be B, for example, something like that. But it's still on the empiricism, yeah. And then we also have the relativisms, yeah. It's mostly discussed about the social constructivisms, yeah, and then epistemological and anarchisms, yeah. Which means it's more empiric than empiric itself, yeah. So it's mean like more we cater the theory based on the construction of the simulation that occurred. Yeah. So in here, it's actually show us about I call the argument that work behind scientists when he do a research or maybe some a specific approach that choosing this kind of the philosophy of science construction. So we're using the naive realism, scientific realism, structural realism, we most close with the ambitious. Yeah, this is like we believe that something should be proven, something that should be acceptable by we see the proof in the real world. Yeah, something like that. But we go to the anti-realism. So this is like more defeatist, yeah, and eliminative. Yeah. So we try to more we try more have some thinking that more empiric, yeah, more constructive, yeah, and more generative, yeah. So we doesn't very care about the environment in the real world. The most important thing is my hypothesis is work, yeah. So that's enough, yeah. So that will be the anti-realism. Once again, what I want to consider for you is you doesn't need to try to to head this kind of the mainstream about the realism but and anti-realisms. Maybe in the level of the Russell, Popper, David, and then Karnav, Kuhn, maybe in that time they will fight with the argument of the realism and anti-realism. But now I think we on the science should be more open, and then we open the act point or maybe the wider opportunity to develop more aggressive about the science itself. Yeah. And it's work for any kind of science. Yeah. So if you learn about economics, I think it's also same. They also have the realism, and they also the anti-realism. If you you learn about engineering, same. Yeah. So everything will be the same. So in this case, once again, you see the landscape that that's why many approach, yeah, many different point of view of the science. Yeah. So maybe it discuss one things here, one issue, but sometimes when we discuss one issue, it will be discussed in many point of view, yeah, and all the point of view is actually is not against each other, but but it will be develop a complete construction of the science. So that's very important. So hopefully, when we see like in our department, we have a department of the computer science and electronics. So we very I think we are very lucky, yeah, to have this department because all in the place, yeah, all in the one place. So it's mean we can see that very complete structure of the science, especially in our faculty. I think we have colleagues in the physics, chemical, mathematics, all the subject will be discussed mostly in the intersection of the realism and anti-realism, and we also in that place. Yeah, so that will be the next one. So I still agree that the computer science it should be not become independent faculty. Yeah, but in this context, in the computer philosophy, especially in the philosophy of science, I still agree that it is one of the construction of the big science, which is natural science. Yeah, so I think that will be good enough. But in the very pragmatic way, yeah, I also believe that computer science should be one major faculty. It should be, yeah. So that will be a different kind of implementation of realism and anti-realism. Yeah. So this is like we see that on the philosophy of science, actually, we realize that many scientists have their own perception. You, a student, is also have your own perception. Maybe you will be a person that more rational, so have the will be select the people that rational. So maybe you will be the people like empirics. So you'll be positive. You'll be pragmatic. Maybe you will structural and so and etc. And it's reflected, yeah, on our department, for example, like me and also my another lecturer in a computer system and network laboratory. We are maybe like more people that on the place of the positivism and realism, so, because we work. There is our research work is mostly like in the real world environment. So, but maybe another lab will be in the different place. Yeah. So in that point, actually, we not consider to head between the lab, yeah, which one the better and so on. No, I think all on the place and then make the philosophy of science become a complete contraction of science. Without computer system and network laboratory, there is no our department. If there is no software engineering and data laboratory, there is no our department, and etc. So that will be our contraction, because all the lab will be placed in this kind of type of the point of view on the to see the philosophy of science. Yeah. Most of them, if the circle is far from the heart of philosophy of science, actually they are the development of the concept, of the theory, of the philosophy of science itself. Yeah. In here we can see that it is existentialism, social contraction, so they involving the perception, they included the social aspect, and also another theory that might be involving their point of view when we see the science. So that will be different things. So when we see the on the philosophy of science, actually in the type of science of and philosophy, we have three type of philosophy. Yeah, all the philosophy actually as general philosophy, but the important things is we have three type of philosophy. The first is natural philosophy. It is close with the natural phenomenon in the world. Yeah, it can be based on the human life. It can be used like animal life, maybe etc. And then we also have social philosophy. This is mostly like interaction between human and also with the environment, and also the spiritual philosophy. This is mostly close with our religion and belief in the community. And in here will be have several categories and also some branches, and then it will be implemented on the engineering technology. In here we can found that mathematics is one of the foundation of the science, and then the interdisciplinary and also the transdisciplinary will be made more comprehensive philosophy. So in this case, we can see that the philosophy is very wide and also is very complex, yeah, and make it more diverse, yeah. So that's why, like in the university, we can found that any university like UGM maybe have some faculty on the natural science and engineering and also social science, but we also have the WIN, ya, Universal Kali Jaga. It's also in the spiritual philosophy. So I think it's also okay. It make in the term of the philosophy more become more complicated and also complete, and also the philosophy become more the development of philosophy is also will be increasing, will be enhanced. We will find have a development, yeah, continuous development of the philosophy itself. So that will be the next one. This is like the example how the philosophy relation between some of the theory that maybe we know. Yeah. So in here, like this one, in the early state, maybe we will have only simple scope on the of the scientific problem that we want to solve here. So and then we try to visualize, and then we try to explain in the very easy way, and then make some prediction, and then we develop theory basis. Yeah. And we can see in here that we can see from the Watson and Crick's double helix model that try to discover these things. Yeah. And then it can be developed, continuous development, continue development. We try to solve the scientific problem that more wider, and then try to make some abstract on there, and then discuss non-physical things, and then we construct the idealization. Yeah. So that's why Maxwell introduced the model for describing this scenario. And when you're using the mathematical formalisms, we can do some model that can use for calculate and then for prediction and so, etc. So that's why we have the Kepler laws of planetary motion. Yeah, so we can predict when the moon will, the things in the space will be moved, and when we can capture the appearance, and then we can analyze the things. Yeah, so that's will be the nice one. And you can imagine that one, the Kepler laws is can identify and also predict. Yeah, so the planet will be in where position. So that will be in other side that we can control the movement of the planet and etc. So that will be one of the work of the best practice how the scientific works. Yeah. So that's the works. Yeah. And of course, because of the because of the development, so I think we also know about the type of the science. Yeah, so we can see in here that the we already now have some theory and also some approach to explain about the atoms, cell, human, earth. Yeah, and then we produce and then we introduce the physical science. Yeah, and then we also produce the life science as branch of science, and then we also introduce social science and also earth science to explain about the earth system. But unfortunately, the solar system, the Milky Way, visible universe still undiscoverable. In other side, the particles that more small than atom is still undiscovered. Yeah. So when we see this one, we can see that the foundation on the branch of the science is actually the formal science, which is mathematics. Yeah. In the mathematics, and the most basic is logic, yeah, reasoning, and philosophy. So I think this course will be the foundation, yeah, to all the science actually. The logic, reasoning, and philosophy will be the basis how the computer science work, yeah, and statistic work, because in there we have a computation modeling, we have a number, we have a pattern, and so on. And then we have the physics. Yeah. So the physics using the mathematics to explain about the particle physics and thermodynamics. And now we also have quantum physics. Yeah. So that's also one of the advantage. Yeah. And then after we have the particle of physics and thermodynamics, we can explain about the phenomenon on the chemistry, which is material and chemical reaction. Yeah. And then after we have chemical things, we have a cellular biology that we can learn about the evolutionary biology. And then of course we also have the functional biology, which is a medicine, ecology, and also psychologists. So in here you can find that we have some advantage because we are in the faculty of natural science that all the place of the basic science. Yeah. So I think our uniqueness on our faculty is on the place. Yeah, so become the basic science. So we need to be strong on the development of the basic science, not go too far to application or other side. Yeah. So because based on our development of the basic science, it will be used by other science to develop their area. Yeah. For example, biology now become the bioinformatics. Yeah, because they can modeling the biological structure using the logic and mathematical things, and then quantum physics is also using the mathematics and physics and other things. Yeah, we also have the new branch of the science, which is geoscience, which is the combination and collaboration between physics and chemistry. So we have a geoscience that we can see in the climate, geology, and oceanography. We also have the astronomy, and then we also have the sociology and the psychology that supported the social science. So in here, once again, if we realize this structure, actually we just realize that uh, every student in our university actually in one of the be one big construction of science. Yeah. So you can imagine if our student is you a student is can interact with other department, other area. It will be very powerful, yeah, to development of the for development of the science. Yeah. So that's why university is one of the place that basic science and also another branch of science will be developed. We have a development in the very progressive way. Yeah. So university will be cannot call us university if not produce the development of the science, yeah, in the good way. Yeah. So that's the explanation about this branch. Yeah. And based on that one, actually it will be support the evolution of knowledge. Yeah. So based on this science, we can now do a lot of some of the development of knowledge. Yeah. So you can see that we have in the very triggering theory about knowledge of the Pythagoras, yeah? And then it's used to develop the Socrates and Plato theory, and then become another theory, which is like in the computer science. Maybe you will see Kuhn in the paradigm theory, and then lack of in the metaphor, yeah, and then another things, yeah. But in the other side of science, we also have a lot of theory that discovered from Darwin, Wittgenstein, and then other scientists that have their own theory. Yeah? So in here you can see that knowledge is support each others. Yeah, even sometimes one scientist will be criticize the previous theory, but it's okay. We can be criticized and then make improvement because of previous theory. Yeah. So that will be the nice one. We cannot be like this because of before it we have a previous condition. So that will be the challenge. Yeah. And so that's why if we try to conclude about the philosophy of science, at least we will have several map that we can see as definition, yeah, in here. So this is like the definition of the philosophy of science that we try to discuss is branch of philosophy that concern with the foundation, method, and implication of science. Yeah. And then this is like we try to do some study from a philosophical perspective that are using the element of scientific. Yeah. So the central question is what is science and what is not science, and then what the characteristic of science. So that is like example how we conclude about the philosophy of science. But still remember that we cannot just claim that we are in the only one correct definition, because still in the theory we have the realism and also anti-realism mainstream on the philosophy of science. So in that case, we need to consider, and then we cannot ignore these two kind of mainstream. Yeah. So this is like the what I call it when we relate it with the research. So of course, actually when we do some research, so for example, you do your thesis, your scriptsy, and so on. Actually, the scriptsy and the research is try to answer the science itself. Yeah. So we have some, for example, research question. We have research methodologies, literature review, all reflected the philosophy of science. So you cannot do your research based on your assumption, your own style. But you need to do with your, I call it your uh, with the reverence, yeah, with the systematic methodologies of science. So it's called, so that's why the research is scientific activity, yeah. So that's the most important things, yeah. And yeah, this is the illustration, yeah, teaching robot right from wrong, how artificial intelligence is learning morality, yeah. So that's will be the conclusion. So that's maybe the conclude of our discussion about the philosophy of science. Yeah. So hopefully, when you hear about this explanation, uh, you can see that the landscape of the philosophy of science is very wide and very complex. Yeah. And then we have the opportunity to accommodate uh, the difference between the mainstream. It's okay. And then in another aspect, it's very important for us to use the concept of philosophy of science in our research and also in our activity, at least for the methodology and also approach. Yeah. So that will be the important one. So the next is discussion. If you have any question, please. Any question from you? Okay, not yet. Okay. Okay, so for yeah, okay, I will stop the recording first.